In 2012, astronomers pointed their lenses toward a tiny flickering smudge of light and realized they were looking at a ghost. This was MACSO 647JD, a galaxy so far away that its light took 13.3 billion years to reach us. But here is the terrifying part. That galaxy isn't actually there anymore. In fact, it's moving away from us faster than the speed of light. Right now, as you watch this, most of the universe is actively escaping from us, slipping over a cosmic horizon where it will be lost to humanity forever. We are living in a fleeting window of time where the stars are still visible, but the curtain is already closing. If we don't look now, we might never know what we've missed. Think about the sheer scale of what we call home. We're told the universe is about 14 billion years old, so you'd think the edge is 14 billion light years away, right? Wrong. Because space itself is stretching, the observable universe is actually a staggering 93 billion light years across. It's a bubble of light in an ocean of darkness. But what's outside that bubble? Science suggests that what we can see is just a tiny fraction, maybe less than 1% of the total universe. Beyond our sight, there could be trillions of other galaxies, alien civilizations, and cosmic structures that we will literally never be able to touch or see. This isn't just a distance problem. It's a physics problem. Imagine space as a giant piece of elastic being pulled in every direction. The further away a galaxy is, the more elastic there is between us, and the faster it recedes. Eventually, that speed crosses the ultimate limit. Galaxies are redshifting into oblivion. We call these galactic holograms because the light we see is just a replay of the past. The physical objects have already crossed a point of no return called the cosmic event horizon. According to our best estimates, 96% of the galaxies we can see right now are already unreachable. Even if we built a ship that traveled at 99% the speed of light today, we would never catch them. They are causally disconnected, gone from our reality. Why is this happening? For a long time, we thought gravity would eventually slow the universe down, like a ball thrown into the air. But about 6 billion years ago, something changed. The universe stopped slowing down and started screaming outward. This is the era of dark energy. We don't know what dark energy is, but we know it makes up about 68% of everything. It's like a built-in anti-gravity property of empty space. As the universe creates more empty space, there's more dark energy, which causes more expansion. It's a feedback loop that is tearing the cosmos apart. When we look at MACSO 647JD through telescopes like Hubble or the James Webb, we see a tiny, primitive galaxy from the dawn of time. But in reality, that galaxy has had billions of years to grow, collide with others, and evolve. It might be a massive, complex system by now, but we will never know its present state. We are stuck watching the infant version, while the adult version vanishes into the dark. It makes you wonder if we are losing 60,000 stars every second to this cosmic expansion. What has already disappeared that we never got to name? What incredible secrets were lost before we even invented the telescope? We are effectively on a shrinking island in an infinite sea, and the tide is coming in. Some scientists believe we are the lucky ones. We live in a unique era of cosmic history where we can still see the evidence of the Big Bang. But this golden age of astronomy is temporary. As dark energy continues to push space apart, the universe will eventually become a very lonely place. In the distant future, every galaxy outside of our immediate neighborhood will be pushed so far away that their light will never reach us again. They will fade, redden, and then blink out of existence. If humans, or whatever we evolve into, are still around in a few 100 billion years, the night sky will look completely different. Instead of a sky filled with billions of galaxies, they will see only one Andromeda. This is the massive supergalaxy that will form when our Milky Way and the Andromeda galaxy finally collide and merge. Gravity is strong enough to hold our local group together, but it's not strong enough to fight the expansion of the rest of the universe. For those future civilizations, the universe will seem to end at the edge of their own galaxy. They might never know that other galaxies ever existed. They won't see the cosmic microwave background. They won't see distant quasars. They will live on an island in a total pitch-black void, thinking they are the only thing in existence. It's an unsettling thought, right? It makes our current discoveries, like the Max Galaxy, feel much more urgent. We are witnessing the final acts of a cosmic show that has been playing for billions of years. But even with our advanced technology, there are still massive debates about how big the total universe really is. Some models suggest that the unobservable part of the universe is 15 million times larger than what we can see. Other theories suggest the universe might even be infinite. If it's infinite, that means everything that can happen is happening somewhere out there, beyond the reach of our telescopes. But if the universe is expanding into a void, what is that void? The truth is, space isn't necessarily expanding into anything. It's the fabric itself that is stretching. It's hard to wrap your head around because our brains aren't evolved to understand four-dimensional expansion. We want there to be an edge, a wall, or a boundary, but the reality might be much weirder. We might be part of a multiverse, or we might be living in a curved space that loops back on itself like a giant hall of mirrors. So, what are we missing right now? What moved over the horizon before we were even here to look? We've already lost 96% of the view, and the rest is fading. We are currently in a race against time and physics to understand where we came from before the evidence disappears forever. Every time we look at a distant star, we aren't just looking at space, we're looking at a memory. And eventually, the universe is going to stop sharing those memories with us. We are the last generation of observers who get to see the full picture. The question is, what are we going to do with that knowledge before the lights go out?